Hey everybody, Mr. Field here, and today we're going to be talking about triangle basics. So if you can go to your OneNote and make sure you get to this section here, triangle basic notes, we're going to kick this bad boy off real quick. So I'm actually going to switch over to my key so we can have you copy down these examples. So this next unit is pretty short. It's on triangles, and a lot of the information, the vocab, so to speak, is information you already probably know. So I'm just going to kind of fly through this real quick. If you could write these down, all these different terms, in terms of triangles, right? So some of these terms you've probably seen before. Some of these theorems that we're going to chat about, maybe you haven't talked about before. So let's jump into it. So first and foremost, you need to be able to classify triangles either based on their angles or their sides. So important info about a triangle, we obviously know it's a three-sided shape, has to have straight edges. They always have three angles, which each have their own vertices. So there's three vertices, there's three angles, and there's three sides. Those are the parts that make up a triangle. And then we can classify them based on those parts. So in terms of classifying via angles, make sure you get these examples down. An acute triangle is a triangle with three angles that are less than 90 degrees. A right triangle can only have one right angle. We'll talk about why in a little bit. And finally, an obtuse triangle can only have one angle that's greater than 90 degrees. So that's classifying triangles via their angles. We have acute, obtuse, or right. Classifying triangles based on their side lengths, another type of quiz question you'll see, is either the options are scalene, isosceles, or equilateral. So a scalene triangle is a triangle that has no sides that are the same length. There's no congruent sides, no equal sides. An isosceles triangle, of course, is one where two sides are equal. And then finally, an equilateral triangle, you've probably heard of that before, is a triangle where all three sides are equal. So those are the basic names you can use when classifying a triangle. Now, typical quiz question, it might ask you to strictly classify the triangle based on the angle measures, which means you would say acute, obtuse, or right. It may strictly ask you to classify the triangle via the sides, so you can say scalene, isosceles, or equilateral, or it might actually ask you to do both, which is possible. So you got to make sure you read the directions. Anyway, hope we got a chance to write those down. Just a quick summary, right, of these. Again, there are combos as well. So if it does ask you to classify the triangle based on its side lengths and its angle measures, you could have any of these options. So starting with acute, right, if we move our way across the row, you could have an acute scalene triangle, meaning that it's acute because it has three angles that are less than 90 degrees, and it's scalene because no sides are the same. So on, we could have an acute isosceles triangle. Again, it's acute because three angles are less than 90, but it has two sides lengths that are equal. And then finally, you could have an acute equilateral triangle, meaning, well, all three angles are less than 90 and all three sides are equal. Notice, in terms of the right triangle, you could have a right scalene, meaning it's got a right angle, but has no sides that are the same. You could also have a right isosceles triangle, meaning, again, it's got a right angle, so that's why it's considered a right triangle, and then it has two equal sides, meaning it's an isosceles and it's right all at the same time. However, you can't have, this is no bueno, not possible, an equilateral right triangle. And we're going to talk about that a little bit later in this unit, why that is. Finally, there's the obtuse options. So we have obtuse scalene, meaning it has one angle that's bigger than 90, but no sides are the same. And then we have the obtuse isosceles triangle as well, where we have one angle greater than 90 and two equal sides. So you're going to have all these different options as it turns out, and you got to make sure you look at the picture and decide which one you have going on. And again, you can't have an obtuse equilateral triangle, and we're going to talk about that because there happens to be this relationship between the angles and the sides of a triangle, but I don't want to spoil that just yet. We'll talk about it a little bit later. So that being said, I'm actually going to switch back to my other spot because here's what we really going to know. Now that we know how to classify the triangles based on their angles inside, so essentially we know what type of triangle we're working with. Now we have to be able to use this thing called the triangle sum theorem. Sum meaning adding, right? Theorem essentially meaning rule, and of course we're dealing with the shape of triangles. So similar to what you've seen before, I know, for instance, if I'm going to call this, and again, if I'm calling this triangle ABC, remember every triangle has three sides, three angles, three vertices. So again, I would name this, it's kind of simple, triangle ABC. I know it's not crazy, the triangle symbol is a triangle. Well, look at that, who would have thought? So again, I could call this triangle ABC, CBA. There's lots of ways to order the letters. It doesn't actually really matter because in this case, unlike an angle, right, if I had angle ABC, well, the vertex would be B, right? It has to be the letter in the middle. That's important. However, in a triangle, there is no angle that's more important than the others. So, well, we can just call it ABC, CBA, BCA, any combination that you want. So, triangle sum theorem essentially tells us that we can do angle A plus angle B plus angle C, and we know they are supplementary. They add up to 180 degrees. The interior angle sum, or sometimes you'll see them say IAS, interior angle sum. It's an abbreviation for the interior angle sum of the shape. In a triangle, they always add up to 180. So again, we see this theme of geometry of piece plus piece equals whole. And then, of course, there's two ways to think about this, right? When we're looking for an unknown number, typically we call it x. So you could always set up an equation. There's nothing wrong with that. We could say, hey, x plus 35 degrees plus 80 degrees equals 180. And we can combine like terms and go from there. So I'm thinking, well, 80 plus 35 should be 110, and then the 5 should be 115. If I'm not mistaken, we're going to subtract 115 from both sides. Oops, 115. To get x by itself. Apologies for my sloppy handwriting. Well, if we subtract 80, that's 100, and then 30, that's 70. So I'm thinking we should get x is 65 degrees. And again, we could always check using our handy dandy calculator by just adding everything up. So there's example one. Again, the triangle sum theorem states that if you add all three angles in any triangle, doesn't matter which type, they always add up to 180 degrees. Let's check out example number 2. So getting a little more complicated, but hopefully not too much. Again, we're dealing with triangle like ABC or CBA, however you want to start and call it. But I know for sure because of the triangle sum theorem, and it doesn't matter any type of triangle, whatever one I have, and there's three angles and they're always supplementary, they add up to 180 degrees. So essentially, if I take all of the expressions that are representing angles A, B, and C and add them up, right, they should add up to 180 degrees. So you can write this giant long, expression or equation, I guess is actually the best way to say it. Let's be mathematically correct here. You can absolutely do that, but I'm hoping at this point in our mathematical careers, right, we're getting comfortable with combining as we go. Like I could just realize like, hey, 3, 5, and 2. Well, 3 plus 2 is 5x, and 5 plus 5 is 10x. So I know I'm going to end up with 10x. So we can kind of just jump to that conclusion, right? So I know like 28 plus 52. Well, if I had 50 plus 20, that's 70. 8 plus 2 would make it to 80. And then 80 minus 10, right? So I'm combining all these terms, like terms, pardon. 80 minus 10 should be a plus 70 equals 180. And again, we're off to the races. We know how to solve an equation. We're going to subtract 70 to get 110. And x should be 11, if I'm not mistaken, because 180 minus 70 should be 110, and you divide by 10 and get 11. Now, if we really wanted to check to make sure we were correct, we could always just plug these back in and check. So, like for instance, 3 times 11 is 33. 33 plus 28 would be 41, 51, 61 degrees, if I'm not mistaken. I know like 11 times 5 is 55. 55 plus 52 should be 107, if I'm not mistaken. And then 22 minus 10, right, that should be 12. And I believe if we check, use your calculator, it does add up to 180 degrees. So we should always be able to walk away from these knowing that we have the right answers. But most importantly, just because you have x, don't just assume that you're correct. I'm thinking we should have angle A is 61 degrees. Don't forget that symbol. I'm thinking we have angle B at 107 degrees. And of course, angle C at 12 degrees. So that is applying the triangle sum theorem. So a bonus question really quick, if you want to pause the video, think about this for yourself. Looking at example 2, looking now that we know the measures of these angles, right? Could you classify this triangle based on its angles? Essentially saying, well, is it going to be acute, obtuse, or right? I'm thinking it's going to be obtuse. Why? Because we have one angle, 107 degrees, right? That's larger than 90, and all the other angles are considered acute. So I would definitely say this is an obtuse triangle based on its angles. We actually, at the moment, don't technically have enough information to know or classify it based on its sides because they didn't give us anything to represent its side lengths. However, later in the unit, we actually will realize we kind of do actually have enough information. I'm going to go ahead and give a little preview. This actually would be an obtuse scalene triangle, I believe. And we'll talk about that later in the unit. And I don't want to give too many spoilers away. All right, next comes to probably the toughest part of this course, okay? Or at least this section. It's called the exterior angle theorem. I like to always say, get hungry because you're about to eat right? The exterior angle theorem. If there's a problem on this next assessment coming up that you're having trouble with, it's probably due to this, right? There's a special relationship between what they call the remote interior angles, in this case A and B, and then the exterior angle D, all right? So let's discover. So if I told you that, let's say that angle A was 60 degrees, angle B was 80 degrees, right? Now, according to the triangle sum theorem, if we chunk our problem, my favorite thing to do, let's just act for a moment like angle D isn't there. We don't care about it. And let's say the problem said, hey, can you tell me the measure of angle C? Well, we know interior angle sum has to add up to 180 degrees. So if I take 60 plus 80, I'm thinking that gets me to 140 degrees. And then if I take the total, the sum that every triangle has to be, and subtract the chunks that I know, the two angles I know, in this case A and B, I know that angle C would have to be the remaining 40 degrees. There's no doubt about it. Now, using that relationship, we've talked about this relationship, this different relationship back in the first unit. There's definitely a relationship between angles C and D, and I hope that I'm highlighting this and you're realizing these are an LP, or what's called a linear pair, which means, again, linear means line, line means 180 degrees. There's two angles that make a straight line and add up to 180, and this is where hopefully the voila moment is kind of popping up, the aha moment at least, popping up in your head. This relationship, if this angle is 40, then this has to be 140 degrees. Why? Because they have to add up to 180. So using, this is what I would consider the long way, but we found C first and realized it's, 40 degrees. And then using our relationship from before, angle D would then have to be supplementary to it, or the supplement of 40 degrees, 140. However, that's what I would call the long way. The other thing you can do is get hungry and eat. I know, essentially, if I add angle A in this case plus angle B, it automatically equals angle D. They have to be the same length. So the exterior angle theorem allows us to essentially say, hey, if I add the two given angles on the inside, it equals the one on the outside. Now that has to be the two what they call remote interior angles, meaning they're not, A and B, notice they're not right next to angle D. C is the one that's adjacent to D. So it has to be the two remote or non-adjacent, not next to angles. So they're called remote interior angles. Long story short, A plus B equals D. And a lot of the times this can be kind of sneaky and confusing. We have a bunch of trouble. So there's a whole bunch of examples of how we can use the exterior angle theorem to help us solve. So let's look at example 3. Well, and we got to start somewhere. And my favorite strategy is chunking. So at first, well, let's look inside the triangle and see if we have enough information. And I'm thinking we don't, right? We know it's a right angle, so this is 90 degrees, which is fantastic. But in order to use the triangle sum theorem, we got to know at least two of the three angles inside the triangle. And we don't. So we must have to use this 150 in some special way. And again, everything in geometry builds. It just keeps going, baby. Linear pairs, vertical angles, alternate, interior, alternate, all that fun stuff. They don't go away. Keep using them, right? So this has to be 30 degrees. It's not because of magic, right? It's because of math. I know that these are a linear pair. They have to add up to 180 degrees. So that angle's 30, and that's what kind of blows the problem wide open for me. I know angle UST is 30 degrees. So now if I chunk the problem again, now we have enough info. The sum of the interior angles in any triangle is 180 degrees. So if I take 90 plus 30, that's 120 degrees. If I subtract, I know angle T at the top there has got to be 60 degrees. Simple as that. So they're like little puzzles. We're going to use this newfound information, these two new theorems, especially the triangle sum theorem, in order to solve. Now, example 4 is the prime example of a problem on the next assessment where people are going to jump on the struggle bus, and I don't want you to do that. Typically, if you're having trouble, you're not sure what to do, it's probably time to get hungry and eat, meaning use the exterior angle theorem. In fact, this is the only way we can solve this, because if you compare example 3 and example 4, in example 3, we can actually kind of reason through it. Again, we talked about, hey, well, at first I don't have enough information because we actually didn't know that angle right there. We didn't know that it was 30 degrees. But we could work backwards to realize, well, since this is a linear pair, meaning we could use information from older units to help, we could say, hey, well, if this is 30, now I'm off to the races, right? I have enough information. I have at least 2 of the 3 angles to solve using the triangle sum theorem to solve for the third missing one. Well, in this one, we don't, right? We definitely don't know what this angle is. They have 84 degrees as angle U. We have angle T being represented by an expression. So we can't just like take 180 and subtract 84 and then subtract 10x minus 3. They're not like terms. So this kind of leaves us in a bit of a pickle. So the game plan here is we got to get hungry and we got to eat. We're going to use the exterior angle theorem. We're going to essentially say, hey, if we add the 2 on the inside, meaning the 2 angles on the inside, it equals the one on the outside. If we add the 2 angles on the inside, it equals the one on the outside. Keep in mind, it has to be the 2 remote interior angles, the ones that are not right next to this angle. And clearly, those 2 angles are not directly adjacent to the angle that's being represented, in this case, TSG, on the outside by 21x plus 4. So we add the 2 on the inside, it equals the one on the outside. We know we can say 10x minus 3 plus 84 equals 20x plus 4. That's the exterior angle theorem, baby. Get hungry and eat. And if you're getting confused on a problem, you're like, wow, I just don't have enough information, I can pretty much guarantee you it's time to get hungry and eat. Use the exterior angle theorem. If you add the 2 on the inside, it equals the 1 on the outside. So I'm thinking we're going to get 10x plus 81 equals 21x plus 4. I'm going to go ahead and subtract 10x from both sides. I'm actually going to move my x's to the right because, well, 21x is larger. I'm trying to play chestnut checkers here, think ahead and try and avoid some negative numbers, some negative coefficients in front of my variable. And then again, if I'm moving my x's to the right, well, this 4 has got to go to the left, like Beyonce. Here we go. So I'm thinking we're going to get 77 equals 11x, which, hallelujah, 11 goes into 77. A nice even 7 times. So we're happy. Then are we done? Of course not, right? Now that we know what x is, we should probably plug it back in to make sure we get the correct answers. So I'm thinking, well, if we plug it in for, we're looking for GST, which is the large angle. Well, 21 times 7, I'm thinking, is 147 plus 4, which should be 151. Sorry, 151. Excuse me. And then we can make sure we do the other angle it's looking for, UST, which kind of silly, but it should be the one that's next to our angle. Notice this is the linear pair, U to S to T. So we're looking for this chunk here. So the fastest way would be to just take 180 and subtract 151 and get, well, 29. Why is that? Well, because they're supposed to be a linear pair. And you can always look for that relationship. They're going to pop up a lot throughout the rest of the course. And if you really wanted to check, we could plug in, 7 in for x and say 70 minus 3 is 67 degrees, right? And then everything should add up. I'm pretty sure 67 plus 84 is 151, meaning if you add the 2 on the inside equals 1 on the outside. And I believe that if we plug in 29 here, everything adds up to 180, so we're all happy. Yay. All right, so what I'd like you to do is pause the video real quick, try these guided practice problems, and let your teacher know if you have any questions. All right, so we hopefully you got a chance to finish those. Before we move on, I just want to do a couple quick examples before this video concludes because it's getting a little long. So classifying triangle examples, all right? So again, it says classify by its sides. It's not asking us to classify based on its angles, because notice in the first couple, we actually don't know anything about its angles. So number 1, I'm thinking I would call it equilateral, meaning all 3 sides are the same, okay? Number 2, I would call it isosceles, because at least 2 of the sides are the same. That's actually the same thing that's true for number 4. Remember these little congruence marks? Well, they're going to apply in these pictures as well. And then number 3, I'm thinking would be what's called scalene, right? None of the sides are the same, so it's got to be scalene, okay? And next section, hopefully pretty straightforward. Classify the triangle based on its angles. Well, I'm thinking, well, the first one's going to be a right triangle because it has a right angle right here, okay? I'm also thinking it's going to be, well, let's not spoil anything. I know it's going to be scalene, but we'll talk about why. I don't want to give away the magic just yet. Number 6, I'm thinking this is also going to be acute, and I also happen to know it's scalene. Maybe you can think about why. Number 7 is not only going to be isosceles because of these two angles, but I think it's going to have something going on with the sides as well. Again, there's this relationship between the angles and sides, and maybe you're picking up my hints. I don't know. And then, of course, number 8 is going to be technically acute, but there's another term, technically you can call it equiangular. I would totally accept that answer as well because they're all 60, 60, 60. So, that being said, thanks for watching. I hope the Triangles Basics video was pretty good, and keep up the good work.